Hello, my dear students. Welcome back. So this will be the part 3 for the 4th chapter, carbon and its compound. Okay, and this chapter, this chapter is very important. Okay, this chapter now it's a long chapter, so we'll continue all the topics that are included like in this chapter. Clear? So in the last class, we have discussed about the hydrocarbon, types of hydrocarbon, and we have discussed the uniqueness. Okay, we have discussed about the versatile nature of carbon, right? So today we'll discuss another important topic, that is isomerism. Okay, isomerism. Isomerism. Okay, now in a simple word, let me give you an example, okay, for isomerism. Isomerism means there will be a compound, okay. Now it's a different compound, but they will have same formula, clear? They will have same formula, but their structure is different, okay. So let's say we'll take N-butane and isobutane, okay, isobutane. Now, butane, as you all know, right? Butane, as you all know, it is, the formula would be, but means 4, right? But means 4. Now, this is the formula for butane, right? C4H10 is the formula for butane. Now, isomerism means it is a compound, okay? It is a compound where we'll have a same chemical formula but different structure. Clear? Now, for N-butane, now let's say we have 4 carbon. We have 4 carbon, okay? 1, 2, 3, 4. Now you count. We have 4 carbon and we have 10 hydrogen. 4, 4, 8, 9, 10. Right. Now isobutane, okay. Isobutane. See. So when we count this one, we have 4 carbon, we have 3, 6 hydrogen, right? We have 3, 6, 7, 8, 9, 10. So this is also C4H10, right? This is also C4H10. So they have the same formula, but their structure is different. Okay. Now, in a simple word, I'm repeating again. Okay. Now, when I repeat something, that's important. Okay. Now, isomerism means same formula but different structure. Okay. Same chemical formula but different structural formula. Clear? Now, similarly in exam, just don't just write the definition. Okay, if just a 1 mark question, then you can just write a definition, but you have to show the example as well. Okay, you have to show the example as well. Now, when you show the example, you have to mention, you have to draw the structure for both N-butane and isobutane. Clear? So we are done with the isomerism. Now let's discuss another new topic, that is homologous series. Okay. Okay, so students, homologous series, okay, homologous series. Now here, see, we have series, right? Homo means something like same, okay? Homo means same, and then this series means in order, right? In order. So now this homologous series means it is a series of compound, okay? It is a series of compound that have now same functional group, same functional functional group. Okay, so you can just write this point. This functional group will be our next topic. Okay, so I will explain this one. For now, you just write the points. Okay, they have the same functional group, and the most important thing is, you know, like the difference between the preceding and succeeding. Okay, preceding and the succeeding member differ by CH2. Okay, so see, you are aware with this increasing order and decreasing order, right? So one, you know, like in increasing order, you start with small one, then bigger one, right? So in same ways here, you know, the difference between the preceding member and the succeeding member, the difference is just one carbon and two hydrogen. Okay, now the example for this homologous series would be, it can be an alkane family. Okay, alkane family. It can also be an alkene family. It can also be an alkyne family. Okay, now I'll show you an example here. Okay, I'll show you an example here. Now, in alkane family, we have used this formula, right? CnH2n plus 2, right? Now, let's start with 1, 2, 3. 1 carbon, 2 carbon, and 3 carbon, okay? So now the first one we have, see, C1, we don't have to write C1, okay? If you don't write anything, means that is 1. Now, so we have CH4, okay? So that is when N is 1, we have CH4, clear? Now the second one is when N is 2, okay? When N is 2, so we have C2H6, right? Now the third one, we have C3H8, okay? So now I have just written like 3 series, and now you see the difference, my dear students. You see the difference, see. Now if we compare this one, right? See, 1 carbon has been increased, 2 hydrogen has been increased, right? We can see that the difference is, here is like we have increased 1 carbon here, we have increased 2 carbon here, 2 hydrogen here. Now again, if we see the third one, okay, now again there is an increasing of 1 carbon here and 2 hydrogen atom here, so that makes it H8, okay. Now similarly, increase 1 carbon, 4, increase 2 hydrogen, that means H10, okay. Now similarly, you can try for the fifth one, C5, H12, clear? So students, now this is an example of homologous series. In any homologous series, okay, in a series, the difference between the preceding and the succeeding member of the family, it will be just an increasing of one CH2, okay, CH2. Now they will have similar properties, clear? And the difference is just 1 carbon and just 2 hydrogen atom. You can just write the alkane family, okay, and you can compare all the carbon and all the hydrogen. Now when you look one by one, you will see 1 carbon is increasing here. Again, when we go to the next step, 1 carbon is increasing here, right? Now vice versa, if we see for hydrogen, there is an increasing of 2 hydrogen every step. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. So this is an example of homologous series, okay? Likewise, this applies not only for alkane family, but for alkene family as well, okay? If you write the formula for alkene family, if you apply this formula and if you write at least 5, and if you see, you will see the difference is just 1 carbon and 2 hydrogen, okay? Same as if you write the formula for alkyne, and if you just write it for 5 compound, and if you see the difference would be just 1 carbon and 2 hydrogen atom, okay? So this is an example of homologous series. It is a series of compound that have the same functional group, same property, and then here the difference is the preceding and the succeeding member, okay, differ by CH2, okay, CH2. So this is important, so you can just make note of whatever I have discussed, okay. So we are done with the homologous series. The next topic would be functional group, okay. This functional group we will discuss now. Okay, so my dear students, the next topic would be functional group, okay. Now this functional group is very important because it determines the chemical property of a compound, okay. It determines the chemical property of a compound. Now students, let's say in a curry, okay. Let's say in any curry, if you put chili, that makes a major difference, right. Now in a curry, if there is no salt, that makes a difference, right. So same as, you know, in a chemical compound, okay, in a chemical compound, this functional group is very important and they determine the chemical properties of a compound, okay. And they can be, functional group can be an atom, clear, they can be a single atom, they can be a group of atom, okay, they can be an atom or a group of atom. That determines the chemical property of a compound, okay. I have made this definition very simple, okay. In some textbook, the definition will be a little complicated, but in a simple word, this functional group can be a single atom or they can be in group, okay. And they determine the chemical properties of a compound. They will come and they will change all the property, okay. Now, example would be halogens, okay. Halogens. Now when I say halogens, okay, this is the group 17 elements like chlorine, bromine, iodine, okay, chlorine, bromine, iodine. Now we have alcohol, okay, alcohol, the formula is OH, right. Now we have carboxylic acid, so that will be COOH, okay, COOH. So we have lots, okay, and I will explain about how functional groups play an important role in a compound, okay, how they come and spoil and change the compound. I will explain everything, but this is the simple definition with an example, okay. We have more examples, but I'll show you in the next topic. For now, you can just note this one down and note this example, okay. Okay, so students, now, okay, just to save time, I'm writing in short, okay. FG means functional group, okay. Now, let's take halogens, okay. So, halogen, and halogen can be chlorine, okay. Cl is chlorine, Br means bromine, I means iodine, okay. Now, what did I say about the functional group? They are like the salt in the curry, okay. If you put the salt, it makes a difference, right? So, just remember that one. Now, students, IUPAC name, okay. IUPAC name I have written here. Now this is the functional group, and what will happen if this functional group and okay, if any of these come and join any compound, okay, they will change everything. That is what I said, right? So now let's take example of ethane, okay. Let's take example of ethane. Clear? Now ethane, I have, ethane means 2 carbon, right? So this is the formula for ethane, okay? And the structure is going to be like this. Now what happens is this, now these halogens, they are going to come and they are going to attack this one. Clear? Now you take it in this way. Now I have a functional group called chlorine. Okay, chlorine is here as a functional group, and as the definition says, this functional group, they can be an atom or a group of atom, and they determine the chemical property of a compound. So when this chlorine come and attack this one, they will change the property of this ethane completely. Clear? Now this chlorine cannot replace the carbon. Okay, this chlorine cannot attack the carbon, he can only attack the hydrogen. Okay, they can attack more than one hydrogen. Okay, so now this chlorine will come and attack this hydrogen. So what happens after the attack? See, one hydrogen has been replaced by this chlorine, right? So before it was ethane, right? Before it was ethane, but now the name will change. So when we have these halogens, when we have this halogen as a functional group, now you'll write prefix, okay, word root and suffix. Okay, now we'll start with chloro. Okay, the name will start with chloro, and then this one 2 carbon means ethane, right? Chloroethane. See, before it was ethane, right? But after chlorine came and captured this one, the name is already chloro. Okay, chloro. Now see, the other functional group, they will attack this suffix position. Okay, but only the halogen group will come and they will have the prefix name. Okay, they will have the prefix. So this is chloroethane. Now students, what about if this bromine come and attack this one? It would be Br, right? Then the name would be bromoethane. Okay, bromoethane, BROMO, bromoethane. So for halogen, see, the name is chloro. Okay, Br means when they form a name. Okay, Br means bromo. Clear? I means iodo. Clear? I means iodo, Br means bromo, Cl means chloro. So now here, see, since bromine is a functional group here, now the name has been changed to bromoethane. Okay, now from where did we got this ETH? Because we have only 2 carbon. Clear? So that is how we would write the name of the compound when the functional group halogen are there. Okay, now let's see another one. Okay, so my dear students, the next functional group that we'll discuss is alcohol. Okay, alcohol OH. Clear? The alcohol, the formula is OH. Now this is the name of the family. Okay, we have different types of alcohol. Okay, now okay, OH. So students, now let me tell you that this alcohol, now see, the alcohol that is that we have in the deodorant or maybe in the hand sanitizers and all, is different from the alcohol which people take as a beverage. Okay, that is different. So we'll discuss all about that in this chapter. Okay, now I'm taking the same example ethane. Okay, I'm taking the same example ethane. Now here is the basic difference. Now I have ethane, right, my dear students? I have ethane here. Now alcohol as a functional group is going to attack this compound, right? So now what will happen if this OH comes and forms its position here, okay, becomes a part of this family? What would happen? OH has displaced 1 hydrogen, right? Now see, now it is totally different from ethane, right? So this one, now see, for halogen we started from prefix, right? But for alcohol, it will be in the suffix, okay? It will be in the suffix. Not only alcohol, but the rest functional group, it will end in the suffix, okay? For halogen, we have started in the beginning, right? Chloro, bromo, iodo. But this one, we are going to place them in the suffix, okay? So it will be word root plus suffix. Clear? Now, 2 carbons, so I'll write ETH, AN. Okay, now alcohol, the suffix will be OL. Okay, OL. So it will be OL. Clear? Ethanol. Now the formula is different, right? We have CH3. CH3. Okay, see. CH3 again, CH2, CH2, and in the last we have OH. Okay, so before it was C2H6, right? Ethane. But now, after alcohol came and joined this compound, they have already changed the chemical property. So that is how functional group play or they act. Okay, how functional group act in a compound. See, so now it was ethane, but now it is ethanol. Okay, ethanol. And how you know that it is alcohol? OH. Okay, so today you write all the functional group, okay, because again the next topic will be dealing like more about this ethanol, okay, and this ethanol is the one which is used in the beverage, okay. We have methanol as well, that is also a family of alcohol, okay, but that is different now. So write all the functional group that we have discussed. We'll continue with more new topics in the next class. Thank you so much, students.